Well, hello. Today we're going to take a quick little look at centroids, and then there'll be following videos on how to solve and do some things and some notes in class with them. So as we look at the centroids, centroid is the object's center of gravity or center of its mass, and we label it with the circle and the two different colors there, the black and white. So hold my finger on that dumbbell, it balances right at that center point. It's at its equilibrium when we're balancing there. So equilibrium, keeping everything balanced, looking at the moments, looking at different things. We've done it at our levels in Unit 1. We want everything balanced on both sides. So that's where we try to find that centroid location. So like the fulcrum on a teeter-totter. So how is it used with our section? Calculations and how the forces and members interact with each other are derived from that centroid location itself. So as you look at the classic I-beam, the I-beam has a central location off of that I structure itself. We want to find the middle of that because that's where the stress and strain and everything interacts that's being applied to that structure itself. There are some basic objects that we're going to look at in this class. There's a triangle, rectangle or quadrilateral, and a circle. For all of these, if they're nice basic shapes, the centroid is always located on a line of symmetry that's given on the object. If we look at a square or a rectangle, the centroid is located at half the base, comma, half the height. So it's an XY location using this bottom left corner as the origin, half the base, half the height. We get an XY value that's in the middle that's there. For a triangle, we use the right angle and we base off of there. We go a third of the base and a third of the height, and we find the center location, the x comma y of that, and again always based off of the right triangle. And then for a semicircle, because the center of a circle is just the center point, for a semicircle we use the formula 4r over 3 pi. So we take off of that baseline, axis of symmetry is right down the middle, so how far do we go up? We go up 4r over 3 pi. Some of the formulas, they look a little confusing, but the later notes will make them look a little bit better. We have the complex shapes. This symbol right here is sum, so the sum of the x times the area over the sum of the areas, the sum of the y times the areas over the sum of the areas, sum of z times the areas over the sum of the areas. And we'll look at these two different formulas in later note sections as we move along.